So let's see if I can get this going. Okay. So I have the chat here on my iPad. I have the screen capture there. And I think sound should be coming through. Yeah, it is coming through. What's still missing is my Emacs on the new Mac. And it's downloading very slowly because the latest version doesn't run for whatever reason. If this fails, then we will just use some other editor. But I would love to have some version of Emacs at least. Yeah, this is at least a terminal version of Emacs. I'm gonna put the iPad here so I can see if there's something in the chat. Why do I want Emacs? Because Emacs has the cider mode, which is specially for Clojure and comes with auto-completion and all kinds of things, integrates very nicely. So let's first use the terminal-based Emacs and see if that works. So Clojure is running on the Java VM. It uses, yeah, it is basically just one of the many languages that runs on the JVM. I'm using Leiningen as a build tool, which uses these special Clojure files for configuration. You can define dependencies. Basically what it does is run Maven underneath and pull all the dependencies that you need. Maven is a build tool from the Java world. It's very easy to use, the Leiningen stuff. Very quick to set up a program. This is what Clojure looks like, and now we're trying to install, if I can. Do the modifiers work? No, the modifiers do not work. Okay, I need to press escape, which is a bit annoying. Let's see if we can download cider. Is cider here? No, it is not. That was, I think now we got a bundle of new packages. There's cider. Let's install that. A few more other things, but cider is the most important. Hey Fred. Fred Lecky has joined. We are still trying to set up the IDE because this is the new Mac that I'm using and haven't coded much on this except for the Let's Code MS-DOS stuff. So my Emacs was broken. We can try and use the older version. The newest version doesn't work. The older version maybe works. We'll figure it out. And I have one in the terminal, but the terminal version is a bit... Yeah, the modifiers don't work. So I can't press Meta X or Alt X, I have to press Escape X, and that sucks. So, but first of all, yeah, that's exactly what's happening. Let's revert the buffer. Yes. Okay, here we have at least now syntax highlighting, which is already good. In the background, did I replace already? I forgot. Yeah, this is the March version. Okay, this is the older Emacs version, so let's try and open that. Yes, please. Does it work? Yeah, the code signing. Okay. At the very least, Emacs is starting. Let's see if... Bonjour, Necroware. Welcome to the stream. Let's see if we can set it up so that we have slightly bigger fonts for you to enjoy. This is better. And let's see if the cider mode works. So opening up the same Clojure file here, and that looks pretty good. That looks actually pretty good. Cider REPL, cider connect. Was it like this? No, yes, maybe. Start a Clojure REPL. Oh, okay, it doesn't find that thing. Okay, then we do it differently. So I quit here. I go to my main window. So the good thing about Clojure is you can run a so-called REPL on it. That's a read, evaluate, print loop, which is basically an interactive interpreter. Could you please move the windows to the right? Oh yes, okay, because my face is in there. Let's just grab this. No, not this. Sorry for the trippy stuff. Let's do it like this. I think this is better. So now we're done. I think this should be better. Okay, so here we have the Leiningen REPL. Leiningen, as I said, is the build tool. And we're right here in the project with the REPL, and we can already do some stuff. The simplest thing that you can do is do something like hello world. And as this is a Lisp, we are using lists. Lists are delimited by brackets. And then the first thing is the function name, basically, and then come the arguments. Here's just a simple string. And it will say hello world, and then a nil. Because it's a functional programming language, everything returns a value. Print returns the nil value, which is nothing. So that's okay. We can also compute stuff. We can, for example, compute the sum of 1, 2, and 3, which is 6. And we can define and call functions. I can define a function hello, which basically just calls print hello, for example, with a \n, let's say, and then close. Okay, because I think I need to put in some empty parameters. So the second argument is always the parameter list, and now I can simply call hello and it returns hello. So now you got the very basics of Clojure. I should now be able to connect to the REPL on the command line. Yes. And I get the same REPL here in Emacs, which is awesome because I can go here, press one key combination, Control C, Control K, and it will say at the bottom, yes, I compiled your program and found the main function. I can go over here and execute the whole advent of code right there in Emacs, which is utterly useful. So basically we won't be needing the terminal then. Now, what is the advent of code? The advent of code has been running for a couple of years. It is like an advent calendar of sorts, the one with the little doors where there's chocolate behind. But behind every door basically is a coding question. And I did 2 already, although it's already the 6th, because I was busy with other stuff. And you can go to the first one and you get a little story. It's all about elves and Santa. And yeah, every day you can earn 2 stars and you will get 50 stars in total if you solve everything. This year's thing is that we are in a submarine with the elves, and we get a problem problem input file, which has depth associated to it of the ground below the sea level, basically. And our task is to see how fast the sea level increases. That's day one's problem. And there's always two parts of the problem. The first one is very simple. You have to count how many consecutive numbers are increasing. That's, for example, here it goes from 199 to 200 in increased, but for example from 210 to 200 it did not. What does it look like in Clojure code? That was basically this part here. And now come a few things that are very different from your typical basic program or C or Java program. So my input file, I already piped it in there in simple lines of integers or an array of integers. I call this input, and since Clojure is a dynamically typed language, I don't need to define what type this variable is, it's just called input. And then I use this funny thing. This is a threading macro, which takes a collection, and the collection's name is input. Oh, got some error here. Let's turn that off for the moment. It takes the input here and pipes it through the following functions. This is similar to what you would do in a imperative language, where you say, do this, then do that, then do that. So it takes one item from the list of input and pipes it through the whole thing. It will apply the partition function, for example, first of all, and luckily, Clojure comes with a lot of built-in functions, and we can look them up here using DevDocs. Let me quickly enable the Clojure documentation. And for example, we can look up what the partition function does. Partition, yeah, we have those two things here. Returns a lazy sequence of lists of n items each, so we get 2 items each, so the first and the second and the third, because we chose step 1 on this collection. I can run this in the REPL like this. I can call partition with step with the argument 2, and now I'm not gonna say the step, but for example I will put in a list from 1 to 6. This will give me the partitioning 1, 2, 3, 4, 5, 6, but that's not what we want, because we need to compare everything. So what we need to do instead is to take always 2 things and go only 1 element further, not 2 elements. And this will give us the list of items 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. And that's what this thing does. And then we use the filter function, which is also very typical of functional programming, where we filter the resulting list that we saw on the right here according to a certain condition. And the condition is, given that we take 2 elements x and y from the list, and we need to put double square brackets because we always, for a function, we always need to pass the parameters in square brackets. And our parameter is a composite, so it's basically a vector of 2 items. And what it does is it compares with using the greater sign. I could also set smaller than x, y, but this is like that. So for example, if I use that filter, I'm gonna write this again, x, y, and greater sign y, x. And what do we apply this to? Well, obviously we will, I want to do that. So now I'm in here and we need to pass something more into here. So this is, you can already see the disadvantage of Lisp in some ways, that you have a lot of braces. So there's also this problem. So I could pipe just this list here, but I can also take this whole function call and okay, I did that not particularly well. Doesn't work. Why does it not work? Because why does this not work? Because I wanted to show you the advantage. So you can nest all the function calls into each other, but that looks horrible. And I think the threading macro makes it much more readable. Do partition the list, do filter the list, and then count the number of elements. And this is the equivalent to just nesting all the things, but I'm wondering why this is not working. Let's take out this function call and just use something like this: 1, 2, 3, 4, and 6, 5. Yeah, this works. I wonder why the other one didn't work. Basically, we kicked out the 6, 5 because that was a decreasing order, and the other was an increasing order. So that's basically what happens behind this stuff here. So what are the advantages and disadvantages of using something like Clojure or Lisp? So since Clojure is a functional programming language where everything returns a value and where all the data structures that you have by default cannot change, they call this mutation. For example, if you have this list here, this list is always constant. If you manipulate it by, for example, filtering it, a new list will be returned, at least in principle. Of course, Clojure does optimizations and looks at the stuff that you're doing and will do some things in place. And there's also mutable data structures where this whole concept of immutability is a bit more relaxed. But the idea behind this is, if you don't change memory spaces, there were no decreasing. Oh yeah, you're right. Yes, you're right. Anyway, what I wanted to say is, if you have no side effects like that, supposedly it's easier to prove that a program works correctly. If you have a lot of side effects where you mutate a lot of memory spaces, you never know if you call a function twice if it does the same thing as before. In theory. In practice, I think Clojure code is pretty compact. So if I wanted to write this algorithm in C or C++, I would most definitely need quite a few more lines of code. So Clojure code can be very compact and it can be relatively high level for algorithms. What I find difficult, because I'm not very good at Clojure, I do it quite a little bit, is dealing with complex data structures. Mostly you will use what you would call maps in C++ or Java for structuring your data. You wouldn't use classes per se like you do in other languages. And getting your data in a structured manner into Clojure is, in my opinion, a bit harder, at least if you come from a different language. Like me, I'm used to C++ and Java and stuff. What I do like is that it's a very compact language, that it's dynamically typed, which gives you a lot of quick prototyping aspects. So you can just write things like this, and you have the nice REPL here for testing out algorithms, things like that. And as Betty said, there were no descending tuples, so let's do it like this. And then we get the 1, 2, 2, 3, 3, 4, and 4, 6. Does it make sense? Yes, that makes sense. And then we can also use the count function to count all the items in here. And that's that. I did days 1 and days 2, and maybe we can now switch to try and implement day 3, I think. That would be nice. Let's go to day 3. Okay, let's read the description. Day 3, binary diagnostic. The submarine has been making some odd creaking noises. Okay, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. Ooh, okay. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, and then there's a list of binary numbers. Considering only the first bit of each number, there are 5 0 bits. 1, 2, 3, 4, 5, yes. And 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. So 1, yeah, okay. So the first column has more 1s than 0s. The most common second bit of the numbers in the diagnostic report is 0, so the second bit of the gamma rate is 0. The most common second bit of the numbers, okay. 1, 2, 3, 4, 5, 6, 7. Okay, yes. Second column, the 0 is more often. The most common value of the third, fourth, and fifth bits are 1, 1, and 0 respectively, and so the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number 10110 or 22 in decimal. Okay, the epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used. Okay, so basically it's the negated, yeah, it's a negative of this one here. Okay. Multiplying the gamma rate by the epsilon rate produces the power consumption. Okay. Interesting. There are probably a lot of ways to deal with this. And we have, how many bits do we have? Let me turn this up. 2, 4, 6, 8, 10, 12 bits. 12 bits in the input. Let's go back to I have a resources folder with the input files, and we do a input1, input3.txt. And we will add a new block for day 3. And what was the output called? The power consumption. Power consumption. Yeah, let's call it calculate power on the input function. Day 3. How would we go about this? So we define a function called calc power. It takes some kind of input and it will return something. First of all, we need to What could we do? What could we do? First of all, we could try and make sequences, 12 different sequences, and slicing the numbers basically. So let's have a second window with the input so we can talk about this a bit more. Oh, come on. Now my project is gone. Here it is. So what I'm thinking about is that we somehow, right now I get all the lines here, so I get an array of strings, and every string has 12 bits basically. We can either let me think which way to slice this. We can either iterate over one string and count in a map or something at the nth position, or a vector at the end position. We increase if there's a 1, and this is actually a problem that I would be very comfortable in solving with for loops in C or C++. But in a functional language such as Clojure, I think this is actually a bit harder. Maybe. So let's say we want to iterate over all the input lines. We can use the threading macro again, and we can we could also use, we could use a reduce call. Reduce applies a function repeatedly and collapses one big collection to one value. That's why it's called reduce. And the function that we apply could be anything. Usually use something like to sum over everything, you use a plus function or something, and reduce one big vector to only one single thing. We could, in theory, reduce to an output where we get two vectors, one for the ones and one for the zeros, and at every position in the vector it says, at the nth position I have this many ones and this many zeros. Would that work? What would such a function look like? So I define a function which has no name. That is done by just writing fn. And it will consist of some string s, I would say. And if I don't pass any more parameters to reduce, it will use the first two strings. Necoware says, I think you can XOR all the numbers with each other and the final number will be the gamma. And the NOT of that will be the other value. Yeah, we could do that. I think we have XOR as well in bit XOR here. Bitwise exclusive OR, here we have it. We can use that. Just like that. That could be the reduce function actually. But first, we need to convert from string to a integer. Let's look how we can do that. Clojure parse binary string. Not sure. How does it work? Binary number, maybe? Somebody has a solution here, but we're not cheating. We're not looking. Parse, let's say parse base 2. Do we have something like that? Instaparse? No, I don't need that. Does Java have something like that? Because I can call Java functions. Java parse base 2 string. I don't know. Do we have to write our own function? Parse int. Ah, look at this. Parse int with a radix. Yes, radix 2 would be the idea. Let's try this. Java.string. Not sure why this happens. For some reason. Okay, we have a problem with the thing, but I'm ignoring that for now if I can. So it was parse int, and maybe this works. No, that doesn't work. It should work. I have my old code from last year. I think I used parse int there, maybe. At least java.string. Clojure.string? No, I want java.string, I think. How do we parse? No, this is wrong. Clojure.string, does this have a parse function? No, it does not. I know that we can use Java string function in some way, but how? I think do I have to use Java lang.string? No. Integer parse int. Okay, we can try that. No, that doesn't work. Does this take a radix? No, it doesn't. This would be a lot easier in C. Yes, of course, but the idea is that I learn Clojure this way. And every year, it's only this time of the year where I use this, and I have to again and again teach myself how to do that stuff. Two and not two. Yeah, could be. You're probably right. Yes, that works. Perfect. We figured out how to parse. Hello? we found out how to parse. So basically what we want to do is we map an anonymous function which calls integer parse int with this thing and in base 2. So if I compile this, and then run the main function, I should get, yeah, I get all the values in decimal. Ha! This is nice. Then I can call reduce with bit XOR, and that should give me just one value, 668, which, according to Necroware, should be the value that we're looking for. Which is nice. So I'm gonna say we define a variable, and that variable's name was gamma. That variable's name was gamma, and I'm now trying to get this inside of this. Exactly. Okay. And what we can return now as our function is actually a vector which contains, actually we can, let's do it like this. Let's do it better. Epsilon is bit not gamma, I would say. So what are we doing? Let is actually defining variables. So we define gamma as the output of this stuff, which we determined is parse the integers in base 2, and then collapse everything down to one value using XOR. And Necroware says that is the way to go. Let's see, maybe it is. And also epsilon is the exact opposite. Oops, I closed the tab. And for some reason it's huge. Because they say, yeah, at least here I see it's basically the not of the first number. And then we have to multiply both numbers. So what we are returning is just the product of gamma and epsilon. Okay. Do you think this will be good? I'm not sure. That's negative. Can we have maybe an unsigned int? If all the numbers are 1 and there are even amount of entries, we will get 0 in the end. So let's think about it once again. Ah! It was wrong. It was wrong. Too bad. Yeah, okay. So, no. But we can do something similar. Okay. Let's divide this problem into another function. So the bit XOR was a nice idea, but doesn't cut it. What we can do is we can try and count all the ones and zeros. Let's make another function to make this easier. calc gamma, I call this. And I'm not sure, do I want to start from the binary or from it's probably easier to go from the string, because then I can for sure count the number of characters 0 or 1s or whatever in there. Let's first define something called input length, which is no, is it called what is? I know there's a function in Clojure, built-in function length. No, that doesn't exist. I know there's something Clojure length of vector, for example. Yes. Ah, count. Yeah, makes sense. That is easy. Yeah, we probably don't even need a variable for that. It's longer than the whole other thing. Yeah, we don't need a variable for that. So basically we need to know how many numbers are in one row, and then we can say which 0, 1 is more, basically, because the length divided by 2, if we are bigger than that, then we're in the majority. So what I want to do is I wish I could slice this in the other direction, but I can't do that quite that easily. I could do a for loop. There's a looping mechanism, but still thinking if I can do something better. I think I do need a loop, because we definitely need a loop, because we need to know the index. Okay, we have to do a loop. Okay, we have to do a loop. We loop over both the input and the string. Let's first loop over one string. Let's assume we loop over one string. We have a character, which is the nth item of the string. Nth takes a collection and then an index. So yeah, we probably need to loop over two things. Yeah, let's loop over two things. String. Oh. Let's take a look at the loop again. So long ago. And we do recur, yes. Let's look at my old code. I used loop there quite a lot, but it has been 1 year. Okay, this is okay. You initialize with 0, for example, and then you recur at some point. Okay, we can do that. Okay, loops are different than in other countries, languages, obviously. So I will loop, and the first thing I want to take is the first of input. Also, I will have some rest, which is everything but the first thing. And there's also something like that. I think it's called drop. Was it drop? returns the lazy sequence of all but the first n items. Ah, yes. So I can say drop one input. So I will split the input into one string called s and the rest, which is everything but the first thing. Let's take away the inner loop for the moment. Later then we will do something where we do the recursion on the loop. Everything is recursive in Clojure, but it will be handled as a for loop because this is a so-called tail recursion, and the tail recursion can be rewritten into a standard for loop like in C++ or C, which the Clojure compiler does for you, so you don't have to think about that. But loop recur does that. And for the recur, we have to do all the expressions, and the expressions look like this. It's basically all parameters. Here I had 3 parameters, x, y, and trees, and those are the 3 recursion parameters basically. So what I want to do is I want to take the first of the rest, and I want to drop one of the rest, which will be the recursion. So this will take always one bit from the thing and recur. So at first this will be, the first one will be the s and the rest will be the rest. And then when we recur, we will drop the s and take the next one, and the rest will be one shorter. Whew! Okay, let's see if we can do this. Then comes the inner recursion. We loop over the first character, which will be the first from the string. And there will also be a rest, I call this rest 2, where we drop one from the string. Betty has another idea on the XOR. Yeah, while I do my complicated stuff, you probably can think about the XOR. And maybe we get a more simple approach then. We can still do the reduce with the bit XOR. I can still write bit XOR here and have a look. Also, we need to have this behave like an unsigned integer. Is there something like that? Ah, we have something like that. Parse unsigned int. Does this actually give us... No, this still gives us a... Is there something like an unsigned integer class? I would love to know how to get an unsigned integer. That would be awesome. Java and Clojure do not have an unsigned integer type. Oh, that sucks. That sucks. That sucks. Java doesn't have that. Oh, the JVM has no unsigned ints or longs regardless of which language you use. Oh, goodness. That sucks. Yeah, I see that. Which means Okay, so here they are limiting it to 16 bits, which is fine. We only need 16 bits. It sucks, it sucks, it sucks. From what I think, but the bit lengths are 12-bit long. Yes, they are 12-bit long. Regarding Betty's idea and your idea, I think we only have the problem if we have the even number of entries. What if when there's... do we have an even number of entries? Is it actually a problem? Yeah, we have 1000 lines. What if we were to add one more line to make it not even? Like, say, all ones or something like that. If I were to do that, then we would have, or all zeros, doesn't matter, I think. If we add all zeros, we would know that we will get a 0 when there are more zeros. Is that true? Or is that wrong? So if we have 0, 1, 0, 1, the question is there always like an even number? They don't talk about this. Probably the setup is so that there is only there's one bit always more often. Are there no bit shifting functions? Yes, we have bit shifting functions, of course. We can use bit shifting. Bit shift left, bit shift right. Stuff like that. So what about the bit shifting? Yeah, we could use that here in the loop. But I think we can still, but we don't use bit shifting, do we? Oh, this is hard. Let's assume that there's always one bit more common than the other, because they don't specify what happens if they are both the same. Can't we roll everything right by 12 and then count up the ones? I don't get it. We need to count the ones in all the columns. And I think the XOR is probably already fine, except that we need to simulate the whatever, how many bit unsigned integers. So I'm gonna try this trick here. Let's see if that helps, but I'm not sure. Yeah, we still get something extensively negative. Why ever? Why does this not work like they... Okay, they use threading. bit not bit x or 16 radix f. Ah, I get something negative. Not bit and, oh, bit and. Whoops. That wasn't very clever. Yeah, so this way I get something of a reasonable. Ah, I think I need to do this before doing that. If I do that, I get an illegal something or other. And because I need to do map bit not, and I need to do a map with an anonymous function. Sorry for going all crazy here. I still get the negative number. At least I get the same. Okay, what's going on in the chat? Roll each binary number by 12 right, add the result to get the number of ones, then roll right by 11, repeat, etc. We can do that. Yes, we can do that. Why not? We can do that, yes. Shift, roll, yeah. I got what you're saying. Yes, we can do that, I think. Let's do one function that's called add digit. And we get an input. I'm gonna remove this part here. The input will be the unsigned integers that we parsed in base 2. And we will remove this first because we don't need that. We'll thread the input. We will have something called shift. This is the number of bits that we shift. So we will call bit shift we'll shift right, I think, right? What are the parameters? X by n. Okay, that means we have to have a function, and percent is the placeholder, by shift number of bits. Or we can just call it n. Let's call it n. And then we will reduce using plus, I think. Shall we try that? Right now, I'm just gonna try it like this. And I will not return gamma times epsilon. But I will just return gamma for testing. And I will just call add digit. It doesn't work like that. I will call add digit on this. Let's swap the parameters because this is the thread last macro, which puts the implied parameter for the collection at the end. So input is my input collection, and here I say shift right by 11, because if I shift right by 12, then I get nothing. Should be okay, I think. I hope. And that should give us hopefully the number of ones in the last column there. Hopefully. And everything crashes. I don't know how to create a sequence from whatever. So I did something illegal. Andre, hi, welcome. Andre joined. Is this day 3 part 2? No, it's still part 1. We are just trying to figure out how to do that in Clojure. We had different ideas, and right now I have a syntax error in some place, and I'm not sure why, where, or how. So what am I doing? It was complaining in some, probably in this anonymous function or something. Yeah, of course, I need to call map on this. So I will have to call it for every input item. And that should hopefully work. That does work. So this one says 494 ones. Hopefully. I'm not sure that's right. Does anyone want to count? Let's say we delete all this. And we get 2. That's good. That's good. That works. 3. Oh, wait a second. 1, 2, 3, 4, 5. This should give 5. No, it gives 4. Oh. Well, almost. 1, 2, 3, 4, 5. Huh? Ah, of course. 1, 2, 3, 4. Yeah. Okay. It is the first column, of course, because we're shifting right. Okay, good. That means our first bit is 494. We need to do this a bit more cleverly. I'm gonna write this function calc gamma once more. It takes an input and a length that we want to use, and we'll loop over all the different bits. We'll start with 0. Now we'll start with I think loop is the wrong thing to do here. What do we have? We have with a while loop. I realized I did this very stupidly by looping over string arrays and counting character matches. If it works, it works. We're trying to do it on the bit level, but yeah. Since I'm not really good, no, I have not used while in the last thing. I hardly use while. Can you use a range? Okay, yeah, we can use a range. Let's say range 1,111. Almost 1 to 12. Yes, that's better. So we can loop over the number of bits that we have. I think using loops in a functional language is a sign that the mindset is still at imperative languages. I was raised with imperative languages, BASIC, Pascal, C, C++, all that stuff. But I try to figure out the way how to do this in functional languages. And sometimes it looks quite nicely. I think the last 2 days I did okay. There's of course a few let and case stuff and things like that, but a lot of functional stuff here. But I think here, yeah, we can rewrite it later. So we have the bits here. The bits that are to go. Do I want it like this? Let's start with 2, from 2 to 11, and we start with the current bit being 1 or something. This is the first time I discover Advent of Code, says Yuka Yulinki. Hi. It looks like the website does not have the actual problem inputs, just small example inputs. How does one get the... Oh, the actual problem input you get when you are registered. When you are registered, on the bottom of every day you have this thing, get your puzzle input, and you click on this and you will get a huge file. And every person gets a different input file, so yeah, you need to compute your own solution. Nekura says, as one guy I knew said, you can program Fortran in any programming language. Yes, that's true. So we loop like this. We recur by dropping 1 from the bits and taking or doing the first of bits. So this is my recursion. No. Come on, all the parentheses explode. And in between we need to do stuff, magic. I hope. We need to have some kind of accumulator here. I'm not quite sure what that will be. Probably a vector, I guess. Counts, I will call it. And it will be, how do I make a vector with vec? I think like this. Oh boy, how can I do a imperative languages is the most intuitive for me too. Yes, for all of us, but that's why we do this. This must be a something. Oh, come on. I'm not gonna bother with this. I'm gonna just call it like it is. I'm gonna do it like this. Add digit. No. I want to do calc gamma on this input. And I'm just gonna hard code it for 12 bits. That's it. Come on. Is this 12 bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 4, 6, 8, 10, 12, 13. Okay, 1 too many. So, we've got the counts, all are 0, and we will have to do something with them. Right now I'm gonna just pass them like this. But there will be something different there. Okay, what do we need to do? We need to probably have some let, because I need a variable, imperative style. The rotated version will be bit shift right of some kind of I'm not happy. Am I in the right function here? So, we will have some kind of input here. And we'll bit shift it by the number of that's currently here, like input by cur, I think, right? Bit shift right x by n. Yes, the input by current, like that. But the input is actually a collection. So what I need to do is not have this, but call add digit actually. I already have this function. So in theory I have add digit and this is actually not the right way to do that, the thing that we did here. Bit shifting by 11 worked, but if we shift by less, we still have to do a bit and with 1 because where did that because we have to select only that particular bit. If we shift only like by 1 or something, we will count all the bits to the left. And by first shifting right the number of correct bits and then ending with 1, we are selecting only that one bit. And that's important. Okay, so we can call add digit on the current bit using the input. And actually, instead of counts, we have to put this somewhere in here and mutate that count vector. And we can do that by using replace? No, not replace. What is it called? Clojure, replace nth element in vector. There's something like that. Associate, yes. It's called assoc, associate. Can be used on all kinds of things. Assoc key, map key value. Okay. So basically we have to call assoc on counts. The key is the index, which is cur, I think. No, not cur, cur minus 1. So dec cur, and we associate the add digit. Whew. So what do we have here when we call calc gamma? We take the input, loop over all the bits in the range from 1 to 11, but the bits to go are 2 to 10. The current bit is called 1 because we do a shift by 1. Do we actually do a shift by 1? No, we start with 0. Right? We start with 0, I think. And we need to return something. We start with 0, and then we go 1 to 11. Because we need to also count the 0th bit. It sucks. Can we actually do a reverse range? Not like that. Start and step. Oh, maybe with step -1. Yes, that works. But then I would like to see 10 to -1. This is probably better. Better to do it like this. Does it make sense? No, it doesn't. I think it doesn't matter which way we do this. Anyway, we loop over the range 1 to 10, start with 0. First we rotate by 0. These are our counts. Then for every recursion we drop 1 from the bits and take the next bit basically from the range. And then we update the counts. The question is, how do we return the counts vector? Because that's what we are interested in. Let's look at how this works. Yes. Okay. Okay. We need to do something like this. If gleich or equal count of bits 0, then we return counts, or else we will recur. So this is how it works. The recursion will run infinitely, except if you have some condition that breaks off. And our bit vector will at some point contain nothing, because we always drop 1 from the bits. And when it's empty, we just return the count vector. So right now, this should compile. And this hopefully gives us something. No, it explodes. Long cannot be cast to some function. It's trying to do some garbage in line 94. In the add digit, where I called, oh yes, of course, there's one. Yeah, there is one too many of the braces, actually. Index out of bounds. That is good in line 107. We're getting somewhere. Okay. So the ASOC dies, basically. The question is, what does it tell us? Which index that was? Deck cur. Oh yes, deck cur is now garbage because it will be negative. Thank you for spotting that. Perfect. Bit operation not supported for persistent vector. Okay. Good. Then let's not do that. Heribert Hansen, also known as Fratzengeballer, is here. Welcome, another fellow DOS Reloaded user. Yeah, we are fist knee deep, whatever, in Clojure. And code is exploding left and right. So something here doesn't like to do it like that. Do we call it with the right parameters? Add digit current is the bit and input is the input, which is fine. That should be fine. I'm gonna do a print input here just to see what we get there. Okay, okay. I basically get the whole input here, which is fine. That gets then threaded through there. Can counts be constant vector? I think that doesn't matter, Necroware. I think that is not the problem. I think the problem is here in this line. No, it says 118. What? Betty says I'm well out of my depth now. Yeah, me too, me too. I'm barely hanging on. Yeah. That's one disadvantage of such a dynamically typed language. It's very, at least I don't know how to do it properly. It's hard to debug. Let's do this again. It says the problem is in line 118. So let's take a look at line 118. It's down here. Ah, okay, epsilon. Yeah, okay. We don't want epsilon right now. Go away, epsilon. We don't need you. Okay, look at this. Yeah, that's good. We have the counts. And I'm not sure the counts are correct because I see 2 zeros here. This worries me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's definitely something wrong because in the first and the last column there's definitely at least one 1. And in the second and second last as well. Also, we need to reconstruct the actual number from that. But we're getting somewhere. We are getting somewhere. The add digit kind of works. But there is something wrong here. The question is, can we get like a debug output? Can I see when we get the nth call and if we actually call it this often? Oh, look at this. It's only called 10 times. That's a problem. And that's because I need to go from 0 to 12. Almost there. Almost there. I'm just tweaking it until it works. Okay, here we go. It's not the nicest piece of code, but we will have part 1 almost done now. Now we only need to see, basically we know it's, yeah, we know the length of our input. Right after here, right after calc gamma, we know what our vector here is. Let's do it like this. Bit counts, let's call it bit counts, and I'm gonna suck in all this. This is called bit counts. And Can we easily make this a binary number again? Or not? So we know the length of our input is count input. And I can map something like this to my bit count vector, where I say is whatever I have here bigger than the len divided by 2, then I will get some vector with bool values in there which say true or false. True, 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 false, 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 true, 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 false, false. This is basically our bits. We can turn that to ones and zeros. Or maybe we can make a number from that. Not sure. Can I construct a string from this? I'm not sure. You can shift them again to one number. Yes, yes, but I don't want to use another loop. It's so ugly. I'm thinking about using something else. I wonder what we can use. I'm not happy. I am not happy. Let's do it like this. 1 second. You can recurse. Yes, of course I can. I mean, the loop is also recursion. So here we get this, and now I'm doing another function because I can. No, I probably will just use the same like this. I will. I dislike the way I wrote this over there. I dislike this. I will map if this is bigger than that, then I will return a 1. Otherwise I will return a 0. And this should give us almost a string. No, it gives us a function because I forgot to apply it to the bit count vector. Now I got almost a string. Clojure concatenate string. How does this work? Applies to, okay, that's good. Applies to. This should give us a string. It does. And now we can use funky integer parse unsigned int using radix2. Did I pause? Yes. Hi Matze, welcome to the chat. And there we got at least, I think we got the gamma. We are almost, I think I won't do part 2 probably today. It's probably too complicated. But I want to have this finished at least. Okay, the add digit is working. So there's half of DOS reloaded here. Perfect. To everyone who's still hanging on. Okay, we got this number, and now we can try to do epsilon. Let's try if the bit not doesn't work. Does work, sorry. And we will return a vector for now of gamma and epsilon. And it gives us a negative number. And that was one problem, right? But there was this one trick, hopefully, Clojure, unsigned int. We had this, yeah, this trick here. But the problem is, Chris Retro is here. You probably were here for a while, I guess. I don't know, but welcome. And for Matze, Clojure is a Lisp. It's not really C style. It's a Lisp dialect, a very modern Lisp dialect. It's 15 years old or something. Runs on the Java virtual machine. I like it. But it is hard to get used to if you always coded in C and BASIC and stuff, which I did for all my life. But that's why I'm trying to learn this. So some things are hard, but the code can be quite compact and yeah. Bit and not. I'm not sure this will work. So from what I can gather, this should work if I put something like this in there. It gives me a -1. That doesn't make sense, does it? I think not. I actually have a Lisp. Wait a second. If somebody wants to learn Lisp, I have here the Input 64 magazine from 1986, April 1986, with a cassette for the C64. And on that cassette is Lisp 64. So whoever wants to learn Lisp, you can do on the C64. There you have it. But we need to somehow get this done here. So our output is bit and not 3632. And then the Stack Overflow thingy says we should do it like this, and it gives us a 0. That doesn't make sense. 16R F. Maybe. Oh, of course. I did garbage. I did garbage 3632. That's what you're doing. But that's not what I want to see. No, that doesn't make sense. But what happens if I do this? Then I get the 3632, of course, because that does nothing at all. Yeah, I also learned a little bit of Lisp. Chris Retro codes Fortran on a daily basis for my day job. Not kidding. Yeah, there are, I guess, a few Fortran and even COBOL coders out there. And I mean, even C++ is now not as common as it used to be, maybe for games and stuff. But there's so much going on with JavaScript, Java, and stuff like that. All the web is basically not C++. So I consider C++ almost a legacy language. Although, of course, there's still a lot of things happening in embedded and other stuff doing C and C++. Andre loves Julia. Yeah, I never used Julia. I think it's pretty modern. Betty learned Miranda. Never heard of that one. But kids, we need to get this this very last bit to get the epsilon. What if I do something like this? I need to negate that. However, I only need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I get 463 because I only need the 12 bits. Does that make sense? I think this is the definition of the gamma. Or the epsilon. Let's see if that is correct. Let's compute the product. I think they wanted the product, right? We'll see. So I think my solution is this here. And power consumption is the product. That's not the right answer. Your answer is too high. Okay. Okay. Let me get my calculator. Or can I do it on this calculator? Can we go to a programmer mode? Yes, we can. Do we have binary? Show binary, okay. Let's go to a decimal. Let's say we have 3632. Then going, can I do ones complement? I get a huge number, of course. Can I decimal places? Can I set this to like do 12 bits or something? Probably not, right? No. So the important part is this one here. If I do ones complement, I have this. Then I want to OR it with 2 to the power of 12 is 4096. No. Yes. Yes, 4096. So I can do AND 4096. And it's broken. Damn it! Let's try again. 3632. One's complement. And 4096. Why doesn't this work? 4095, right? Yes. Yes, thank you. I noticed. 3632. Oh, Siri activated. I love you, Siri. And 4095. Yeah, of course. One's complement and 4095 gives us 463. Huh? Okay, so my code is actually correct, but it's still wrong. So something is fishy. Did we do the wrong direction? Can it be? Could it be that we should have reversed the... I think we should have reversed the string. I think we should have reversed the string. Ha! Look at this. I say the string was reversed. And this is our actual solution. Gold star! We got it! Good grief, that was complex. And I'm not gonna look at the second task. Not today. No way. So, can we please marvel at our solution once more? We calculate the power by taking the input, converting it to an unsent integer by parsing it in base 2, then calculating gamma for the whole input. And gamma does a recursion by continually bit shifting from 0 to 12, and then calling add digit to count all the digits in one row by using bit shifts, bit ends, and reduce. And then the recursion takes care of that in a vector. And in the end, we basically reassemble the vector with this weird if bigger than 1 or 0 map, and then applying the string function, then reversing the string, and then passing the integer from that. And that's so crazy. And afterwards we bit not and bit end, and then we get the epsilon and everything's good. Whew. So, last deal for today before I close the stream. First, I say thank you very much for everyone showing up on short notice. I thought I'm gonna do this anyway, so why not do a short stream? It was very funny, had a lot of fun. Day 3.1, we commit everything. You can have a look on my GitHub account. The link is in the video description for my repository. Maybe I will do another stream for day 3.2 or whatever day I will do. I hope you learned something. I definitely learned something. Every year, once a year, I use Clojure. I always hope to get better. I think there is some things that Clojure pros would do differently. I think this is still ugly. We could probably introduce a parameter and generate the vector and have this range not hard-coded and stuff like that. And probably this will all come back and bite us in the arse when we look at part 2 of day 3. But for now, it works. I'm gonna tell you have a good night. The pro Clojure solution, yes, it would be nice to see a pro Clojure solution. maybe I will try and Google for someone who's more Clojure proficient than I am and see if they can do it better. But I'm pretty proud of what we did here, and maybe Betty and Nekoware can figure out if the XOR version could work and is maybe faster. I think it's definitely an interesting idea. We did a very elaborate solution here, but maybe the XOR version is doable. I still think it is, especially since here we never have the same amount of ones and zeros. I only think about even and odd numbers that might be a problem. But other than that, yeah, let's see. Anyway, very cool that how performant would this code be? This code here or the XOR code? I think if we had, I mean, this does a lot of string operations and stuff. I think it's, I mean, the inner loop is all on here. This part is all on bits, integers, so that should be really fast. The only inefficient bits are going from the text input to the integers and the other way around when we reassemble. This is horrible code, but I don't know how to do it better. So I think this would scale to a lot of numbers, like huge arrays. Is Clojure actually used for anything useful? Any popular programs coded in it? Says Retroiana. I think there are quite a few systems. The inventor Richicki, he has a company, they do all their software in Clojure, or most of the software, or in Java. They sell their workforce basically to other companies. They also have a database based on Clojure. I think, I'm not sure if it's still the case, I think that Twitter had a backend engine for distributing workloads written in Clojure. So yeah, it is, there's quite a few things that Clojure is used for. It is a somewhat niche language for sure, but the advantage of Clojure is that it runs on the JVM, that you can use all the Java libraries, all the Java toolkits. So you can even write programs in Java most of the time, and if you have certain aspects that map better to Clojure, you can write stuff in Clojure and then write the rest in Java or another language that runs on the JVM, like Scala or something. So maybe you are already using Clojure code day to day and don't even know it because it's only a few classes that are in a Java project or something. It is not the most common language, no, but it has gained a following, and I like it. Even though I'm not good at it. I like the ease of getting this whole REPL and fiddle something and run it. It's almost like, that's also why I like Python, because you just change something and run the script. I don't need to wait for a compiler or anything. It's really, really fast turnaround. And yeah, I like it, but I need to practice it much more. That's it. It's way too late. I need to work tomorrow. Thank you for stopping by, and I think that's it for today. Have a nice rest of the week. Let's see when I will be doing the next stream. I'm probably not going to do all the 25 days. I would love Julia. Okay. Perhaps I will check it out at some point. Need more time. Thank you, everyone. There's more happening in the chat. Yeah. Okay. That's it. I'm gonna end the stream. Goodbye.